Good morning. Now sum number 8. A large chain retailer purchases certain kind of electronic device from a manufacturer. The manufacturer indicates that the defective rate of device is 3%. The inspector of the retailer picks 20 items from a shipment. What is the probability that store will receive at the most one defective? At the most one means not a single defective or one defective item. Okay. Solution. Let capital X denote number of defective electronic device. P is the probability that device is defective. Now 3%. Percent means per 100 for every 100. So P is 3 upon 100. So it is Q 97 upon 100. Now 20 items are picked up. So N equal to 20. So X is a random variable which follows binomial distribution with which parameters 20 and 3 by 100. Now it is probability mass function of X. P of X equal to X is NCX P raised to X Q raised to N minus X. So P of X equal to 20 CX 3 upon 100 raised to X 97 upon 100 raised to 20 minus X. So probability that store will receive at the most one defective item is P of X equal to 0 plus P of X equal to 1. You will notice that this part is important. Simplification. Everybody can write this. So 20C0 which is 1, 3 upon 100 raised to 0 is 1. This is 0.97 raised to 20 plus 20C1 is 20, 0.03, 0.07 raised to 90. Now this can be taken common to get this in bracket. So 1.57 into 0.97 raised to 19. This is the required probability. Now miscellaneous exercise, sum number 9. Okay. The probability that a certain kind of component will survive a check test is 0.6. Find the probability that exactly 2 of next 4 tested components tested survive. Okay. Let X be the number of tested components which survive. P is probability that component survives check test. It is given as 0.6, that is 6 by 10, that is 3 by 5. So it is Q. 1 minus 3 by 5, that is 2 by 5. Also N equal to 4. So X follows binomial distribution with which parameters? 4, 3 by 5. So probability mass function is P of X equal to NCX P raised to X Q raised to N minus X. That is 4CX 3 by 5 raised to X into 2 by 5 raised to 4 minus X. So what is required probability? Probability that exactly 2 components survive. It is better if you write that in words. P exactly 2 components survive. That is P of X equal to 2. That is P of 2. So it is 4C2 3 upon 5 square into 2 upon 5 again square. 4C2 is what? 4C2 is 6. Then 3 upon 5 square is 9 by 25 into 4 by 25. Simplify this. So it will be what? 9654 into 4. So 216 upon 625. If you convert it into decimal, then tell me what will be the answer in decimal. It is going to be terminating 1. Point 3456.
An examination consists of 10 multiple choice questions. in each of which a candidate has to deduce which one of 5 suggested answers is correct. A completely unprepared student guesses each answer completely randomly. What is the probability that the student gets 8 or more questions correct? Draw the appropriate moral.
Okay, this is sum number 10. Now we begin with let X stand for number of correct answers. P is probability that student gets correct answer. What is that? 1 upon 5. Why? Because it is given that in each of which a candidate has to deduce which one of 5 suggested answers is correct. And here actually exactly one answer is correct. This should have been given. But anyway, we assume that exactly one is correct. So P is 1 by 5. What will be Q? 4 by 5. Now in the beginning, it is said that exam consists of 10 multiple choice questions. So n equal to 10. Therefore, random variable follows binomial distribution with which parameters? 10, 1 by 5. So PMF of X is what? P of X equal to X is NCX, P raised to X, Q raised to N minus X. So P of X equal to 10CX, 1 upon 5 raised to X, 4 upon 5 raised to 10 minus X, X goes from 0 to 10. Now what is required probability? Probability that student gets 8 or more questions correct. That is P of X greater than or equal to 8. That is P of X equal to 8 plus P of X equal to 9 plus P of X equal to 10. Substitute 10C8 and so on. Now I have taken 1 upon 5 raised to 10 common because in each term that term is there. 5 raised to 8, I mean 1 upon 5 raised to 8. This also contains 1 upon 5. So in bracket 10C8 is 45, 4 square is 16. 10C9 is 10 into this 4 and 10C10 is just 1. So it is 761 upon 5 raised to 10. Sum number 11. The probability that a machine will produce all bolts in a production run within specification is 0.998. A sample of 8 machines is taken at random. Calculate the probability that number 1, all 8 machines, number 2, 7 or 8 machines, number 3, at the most 6 machines will produce all bolts within specification. Solution. Let X denote number of machines which produce the bolts within specification. So P is probability that a machine produce bolts within specification. So P equal to 0.998. What will be Q? 1 minus that is 0.002. Small n, that is number of Bernoulli trial, 8. So random variable X follows binomial distribution with which parameters? 8 and 0.998. I think 3 sub questions are there. Before that, we have to mention probability mass function. What is probability mass function? It is P of X equal to NCX, P raised to X, Q raised to N minus X. Here particular values. So NCX, in fact 8CX, this is 8CX, 0.998 raised to X into 0.002 raised to 8 minus X. X varies from 0 to 8. First part, probability that all 8 machines will produce bolts within specification. That is P of X equal to 8. That is 8C8, which is 1.998 raised to 8. If only this part is asked for 3 to 4 marks, it is better that you find the answer using log tables, that is simplify this. Otherwise, say that this is the final answer. Second part, probability that 7 or 8 machines will produce all bolts within specification. So P of X equal to 7 plus P of X equal to 8. Substitute the values. What can be taken common? 0.998 raised to 7 can be taken common. So 8 into 0.002, which is 0.016 plus this 0.998. Okay. So addition of these is 1.014 So 1.014 into 7th power of 0.998. As I said, if only this part is asked, simplify this using log tables. In board exam, log tables is allowed. For CET or JEE Main, use of logarithmic tables is not allowed. Third part, probability that at the most 6 machines will produce all boards within specification. At the most 6 means x less than or equal to 6. Now what is the complement of x less than or equal to 6? It is x greater than 6. Probability of an event is 1 minus probability of its complement. So 1 minus p of x equal to 7 plus p of x equal to 8. We have already obtained this. So just subtract that from 1. This is the required probability. Actually, 12 sum is for homework. Let me read the sum first. The probability that a machine develops a fault within the first 3 years of use is 0.003. If 40 machines are selected at random, calculate the probability that 38 or more will develop any fault within first 3 years of use. So we define x in this manner. P is given. From that we can find Q. Number of Bernoulli trial is given. What is asked? P of x greater than or equal to 38 is asked. So P of x equal to 38 plus P of x equal to 39 plus P of x equal to 40. This is approximate answer. 775.44 into 0.003 raised to 38. Sum number 13. A computer installation has 10 terminals. Independently, the probability that any one terminal will require attention during a week is 0.1. Find the probabilities that 0, second part 1, third part 2, fourth part 3 or more terminals will require attention during the next week. Write down. Solution. Let capital X equal to, write down. Let capital X equal to number of terminals which will require attention during a week. Number of terminals which will require attention during a week. Next line, P equal to small p. P equal to probability that a terminal will require attention during a week. Probability that a terminal will require attention during a week equal to 0.1 given, equal to 0.1 given. Therefore, Q equal to small q. Q equal to 1 minus P equal to 0.9. Okay, 0.9. Now see on the screen. Also, what is small n? Number of Bernoulli trial. Also n equal to 10. So x follows binomial distribution with which parameters? 10.1. Write down. EMF is I will directly write 10 Cx 0.1 raised to x 0.9 raised to 10 minus x. Yes, now find out probabilities for 4 events. So first part, probability that no terminal will require attention, that is P of x equal to 0. 10C 0, which is 1. 0.1 raised to 0 is 1. So answer is 0.9 raised to 10. Second part, one terminal will require attention. So P of x equal to 1. 10C1, which is 10. 0.1 into 0.9 raised to 9. 10 into 0.1 is 1. So what is the final answer? 0.9 raised to 9. P of x equal to 2. Why? Because exactly two terminals will require attention. So 10C2, which is 45, 0.1 square is 0.01 into 0.9 raised to 8. So final answer 0.45 into 0.9 raised to 8. But as I said, if only this part is asked, it is better that you simplify this using log tables. Now fourth part is important. Probability that 3 or more terminals will require attention. So required probability is P of x greater than or equal to 3. If you consider original event, you will have to consider P of x equal to 3 plus P of x equal to 4 up to P of x equal to 10. And therefore we consider the complement. What is complement of x greater than or equal to 3? It is x less than 3. Probability of an event is 1 minus probability of complement. But what is x less than 3? Probability of. It is P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. Substitute. I have taken 0.9 raised to 8 common. See, I have done this part orally. 10C0 is 1. As 0.9 raised to 8 is taken common, what remains is 0.9 square, which is 0.81. 10C1 is 10. 10 into 0.1 is 1. So it is just 0.9 as 0.9 raised to 8 is taken common. 10C2, 45. 0.1 square is 0.01. So 45 into 0.01 is what? 0.45. This is taken common. So their addition 2.16. So what is the final answer? Required probability 1 minus 2.16 into 0.9 raised to 8. 14th for homework, but I'll explain important part. In a law school, 80% of the people like mathematics. A visitor to the school asks each of 4 pupils chosen at random whether they like mathematics. First part, calculate the probabilities of obtaining an answer yes from 0, 1, 2, 3, 4 of the pupils. Second part, find the probability that the visitor obtains answers yes from at least 2. Part A, when number of pupils questioned remains at 4, and in part B, when the number of pupils questioned is increased to 8. So as far as part B is concerned, number of Bernoulli's trial is not 4, it is 8. Okay, but initially you have to say that X is number of people who like maths, P is 80% means 4 by 5, Q is 1 by 5. So N is 4. Only in B part of second sub question, N is 8. Otherwise, N is 4. So this is probability mass function. Okay. Now, why 5 answers? Because this is P of 0, P of 1, P of 2, P of 3, P of 4. Interesting part is P of 3 is the same as P of 4. Second, first part, when number of students or people's question remains at 4 and what is asked? The visitor obtains answer yes from at least 2. At least 2 means X is greater than or equal to 2 means 2 or 3 or 4. This is the answer. And in B part, find the probability that the visitor obtains answer yes from at least 2 pupils when the number is increased to 8. So in that case, you will have to consider P of x equal to 2 plus P of x equal to 3 up to P of x equal to 8. Instead, we consider the complement. What is complement of x greater than or equal to 2? It is x less than 2. But note that do not subtract this number. Why? Because here number of Bernoulli's trial is 8. So what is P of x equal to 0? It is 8C0 4 upon 5 raised to 0 into 1 upon 5 raised to 8 plus what is P of 1? 8C1 4 upon 5 raised to 1 into 1 upon 5 raised to 7. So what is the final answer? Final answer is 1 minus 33 upon 5 raised to 8. So that's it for today.